Composition and Structure of the Atmosphere by Dr. Chang. Book 1 of the Introduction to Atmospheric Science series, 2nd edition, courtesy of Nanyang Technological University, Singapore, May 2025.
This book was first published by the National Institute of Education in 2013. It is republished by the Office of Information, Knowledge and Library Services, Nanyang Technological University in 2025. This audiobook and the original ebook are licensed under a Creative Commons Attribution, Non-Commercial, Share-alike, International License.
Chapter 1. What is the atmosphere?
Introducing the Earth's atmosphere. The ocean of air that envelops the Earth is referred to as the atmosphere. It is this volume of air that supports life on Earth. Apart from providing oxygen that organisms need for respiration, the atmosphere is the medium in which the Earth's weather takes place. The atmosphere is made up of a mixture of gases which has developed since the Earth was formed. These gases are normally odorless and colorless and are fairly well mixed. More than 3/4 of the air is made up of nitrogen, and a good 1/5 of the air is made up of oxygen. The other gases make up the rest of the air's volume by composition. However, the air that surrounds Earth is not a continuous, homogeneous layer. Instead, it is stratified according to composition, temperature, and function. These properties vary with both altitude and latitude. In particular, the density of air varies with the altitude at which it is found. Consider the atmosphere as thin layers of onion skin on an onion, and each of these stratified layers are subsequent layers of skin on this onion. For the purpose of understanding the relationship between the atmosphere and weather, the focus for this section will be on understanding the stratification of the atmosphere using the temperature criterion. In fact, the atmosphere can be divided into several layers in altitude, each defined by its temperature. The atmosphere has 4 distinct temperature zones: the troposphere, stratosphere, mesosphere, and thermosphere, each labeled in Figure 1.3. Let us examine each layer in the following sections, beginning with the layer closest to the Earth's surface.
Chapter 2. The troposphere.
The troposphere is the lowest layer in the atmosphere where all organisms live, and where the weather we experience on a daily basis occurs. About 90% of the mass of the atmosphere is found in this layer. It extends from the ground up to about 15 kilometers in height at equator, but approximately 8 kilometers at the poles. In general, temperature decreases with altitude in the troposphere. This rate of decline, also called the environmental lapse rate, is on the average 6.5 degrees Celsius for each kilometer ascent in the troposphere. At the top of the troposphere is a transition layer we call the tropopause, where temperatures are minus 57 degrees Celsius on average. It acts as a lid to the troposphere and marks the transition into the stratosphere. It is important to understand why temperature decreases with altitude in the troposphere, as it is the upward and downward movement of the air in the atmosphere that causes weather. In other words, we need to understand how the lower atmosphere is heated up from the ground. The sun gives off energy constantly and in all directions as radiation. Because of the temperature of the sun's surface, most of this energy arrives at the top of our atmosphere as visible light and ultraviolet rays. When the radiation arrives at the top of the atmosphere, it reflects about 1/3 of the radiation back into space. The dangerous ultraviolet rays are absorbed by the ozone layer, and the rest of the light continues through the atmosphere. This sunlight is either reflected back into space by the light-colored parts of the Earth's surface, such as ice, snow, and clouds, or reaches the Earth's surface and is absorbed. This absorbed heat warms the Earth. Although the Earth is much colder than the sun, it is warmer than the space around it. Thus, the heated Earth will lose energy to space through radiation. As the Earth's surface temperature is much lower than the sun, it emits radiation in the infrared wavelength. The different gases in the Earth's atmosphere allow some solar radiation to reach the planet and at the same time absorb some of the heat radiating from Earth. trapping it, and re-radiating it back to the surface. This process is called the greenhouse effect, termed for the similar warming process occurring inside a glass-walled greenhouse. This effect will be further discussed in Book 2, Energy Balance in the Atmosphere. Since the heat that is absorbed by the Earth's surface will be radiated out into space, the air closest to the ground is heated first, whether by radiation, convection, or conduction. Essentially, the further away the air in the troposphere is to the heat source, the ground, the cooler it is. Recall also that the density of air decreases with height. This means that with fewer molecules of air further away from the ground, the heat stored at each subsequent higher altitude will also decrease. This results in the air being cooler the further away it is from the ground in the troposphere. This explanation works well for the troposphere, but what about the stratosphere, where temperature increases with altitude?
Chapter 3. The Stratosphere.
The stratosphere is approximately 20 to 50 kilometers above the Earth's surface. The temperature increases with altitude in the stratosphere, from minus 57 degrees Celsius at the tropopause to 0 degrees Celsius at the stratopause, at about 50 kilometers. This is where we have to distinguish temperature from how hot or cold you feel. It is all relative. Temperature refers to the degree of hotness or coldness of an object you are measuring, be it water or air. The temperature is proportional to the average kinetic energy of the particles of the object you are measuring. In contrast, how hot or cold you feel is relative. At such high altitudes, air is very thin because of its low density and its lower atmospheric pressure of about 1/100th of the average surface air pressure. Remember, too, that almost 90% of the mass of the atmosphere lies below this layer. Therefore, at this height, air molecules will not collide with many other particles. If you were to step out of an airplane at this altitude, you will feel cold because there are fewer molecules of air colliding with your body. But the point is that the air at the altitude is thin. Interestingly, the ozone layer that blocks out harmful ultraviolet radiation is found in the stratosphere. Therefore, when the air molecules, including the densest concentration of ozone in the atmosphere here, are pounded with a lot more energy than what we receive at the surface, this excites them and makes them move faster and faster. Since temperature really measures how excited the gas molecules are, relatively speaking, the temperature should increase nearer to the source where these molecules are heated. In this case, the nearer the air is to the sun in the stratosphere, the higher its temperature. Hence, temperature increases with height.
Chapter 4. The Mesosphere.
The mesosphere refers to the layer of the Earth's atmosphere that is found above the stratosphere and directly below the thermosphere. In the mesosphere, temperature decreases with height. The mesopause marks the upper boundary of the mesosphere, and this can be the coldest naturally occurring place on Earth, with temperatures below minus 143 degrees Celsius. While the exact upper and lower boundaries of the mesosphere vary with latitude and season, the lower boundary of the mesosphere is usually located at an altitude of about 50 kilometers. The mesopause is usually at heights near 100 kilometers. Scientists find it difficult to study the mesosphere as weather balloons and airplanes cannot fly high enough to reach the mesosphere, while satellites orbit the Earth above the mesosphere. What we know about the mesosphere is that this is the layer in which most meteors from space burn up. We also know that the aurora borealis and the aurora australis are normally found in the upper mesosphere. The stratosphere, mesosphere, and the lowest part of the thermosphere are collectively referred to as the middle atmosphere, and this roughly spans from 10 to 100 kilometers. The mesopause, at an altitude of 80 to 90 kilometers, separates the mesosphere from the thermosphere.
Chapter 5. The Thermosphere.
The thermosphere is a layer of Earth's atmosphere. Although the thermosphere is technically a part of Earth's atmosphere, the air density here is so low that most of the thermosphere can be considered as outer space. Scientists commonly consider anything higher than 100 kilometers from the Earth's surface to be space. This altitude is slightly above the mesopause at the bottom of the thermosphere. In fact, the International Space Station orbits Earth within the thermosphere. The thermosphere lies directly above the mesosphere and below the exosphere. It extends from about 80 kilometers to 480 kilometers above the Earth's surface. Here, temperature increases with altitude in the thermosphere due to absorption of ultraviolet radiation by atomic oxygen in an environment of extremely low air density. Temperatures of the atomic gas molecules can reach 900 degrees Celsius at about 350 kilometers from the Earth's surface. The thermosphere is also the layer in which most meteors from space burn up. In the thermosphere, the temperature of the aurora increases rapidly in the lower thermosphere below 200 kilometers, but levels off with increasing altitude. The sun's activity has a strong influence on air temperature in the thermosphere. Daytime temperatures are 200 degrees Celsius, higher than nighttime temperature, and when the sun is very active, it can be approximately 500 degrees Celsius warmer. In the thermosphere, gas particles collide so infrequently due to such low densities that the gases do not exist as a mixture, but appear separated based on the types of chemical elements they contain. Energetic ultraviolet and X-ray radiation from the sun also break apart molecules in the thermosphere, resulting in atomic oxygen, atomic nitrogen, and helium, rather than their gaseous molecular form. The thermosphere is separated from the exosphere, the region where atoms and molecules escape into space by the thermopores.
Chapter 6. Conclusion.
It is important that we understand the thermal structure of the atmosphere, as it allows us to learn about why the weather we experience is capped within the troposphere. It is a matter of buoyancy. Consider this simple exercise. If you were to take a ride up the atmosphere in a hot air balloon, what would you need to do to ensure that you can reach the stratopores? With some research, you will soon realize the importance of understanding the atmosphere's thermal structure with reference to the weather and other activities that take place in the Earth's atmosphere. Thank you for listening. This concludes Composition and Structure of the Atmosphere by Dr. Chang. Be sure to also explore books 2 and 3 in Dr. Chang's Introduction to Atmospheric Science series. Each textbook is available for free in the Nanyang Technological University Library's Open Educational Resources collection. Important definitions of key words and concepts are presented in the following glossary.
Atmosphere.
The ocean of air that envelops the Earth.
Exosphere.
The layer above the thermosphere, where atoms and molecules escape into space.
Mesopause.
The layer that separates the mesosphere from the thermosphere.
Mesosphere.
The layer of atmosphere above the stratosphere and below the thermosphere.
Nitrogen.
The most abundant gas in the atmosphere.
Oxygen.
The single most important gas for organisms that need it for respiration.
Stratopause.
The layer between the stratosphere and the mesosphere.
Stratosphere.
The layer of atmosphere above the troposphere and below the mesosphere. The ozone layer is found here.
Thermopause.
The layers that separates the thermosphere from the exosphere.
Thermosphere.
The layer of atmosphere above the mesosphere and below the exosphere. Most of the thermosphere can be considered as outer space. The International Space Station orbits within this layer.
Tropopause.
The layer that marks the transition from the troposphere to the stratosphere.
Troposphere.
The lowest layer of the atmosphere where all organisms live and where weather occurs.
Weather balloons.
Weather instruments are carried by this balloon aloft to send back information on atmospheric pressure, temperature, humidity, and wind speed by means of a small, expendable radiosonde.